lot of you might recognize this as kind of a twist on the Chinese Remainder Theorem. Now, I've always just kind of memorized the Chinese Remainder Theorem, but I'm just going to build it up. I'm not even Remainder Theorem, CR, Chinese Remainder Theorem, I guess we'll call it, right? CRT, Chinese Remainder Theorem. Now, I'm not going to appeal to it directly. I'm just going to do it from first principles, more or less. Now, let's start out, and again, we're looking for the greatest negative integer, not just a positive integer or least residue thing. We're looking for the greatest negative integer solution to this system of congruences. X congruent to 6 mod 14, X congruent to 12 mod 17. Now, just a brief review on what we mean by multiplicative inverses. That's a big deal with respect to how the Chinese Remainder Theorem is derived. Now, an example here would be 2 times 4. And these are examples of a pair of multiplicative inverses. And I'll put mod 7 because it's easy to do this in your head. Now, in much the same way that 3/5 times 5/3 is 1, 2 times 4 is its functions exactly the same way. This is 2 times 4 gives you 8, and 8 minus 1 is 7, right? So 2 and 4 are said to be multiplicative inverses of each other. Now that comes into play really big time here. Let's move along and take a look. It gives us a way to construct solutions to this system of congruences without even knowing what the Chinese Remainder Theorem is. Okay, so what we're going to do right here is find the you see how this is kind of a duality here? We're looking for the multiplicative inverse of 14 mod 17 and conversely. Okay, now it takes just a little bit of time here to realize that A is equal to 11, and that takes a little bit of calculation time. So A is equal to 11, that's the multiplicative inverse of, I should say equal to 11. We can say congruent to 11, but A is equal to 11. Okay, we can say congruent if we want to, but you can say A is equal to 11. Now, the reason why is 11 times 14 is 154. 154 minus 1 is 153, and that's 9 times 17. 9 times 17 is 153. Okay, so that's why A is equal to 11 is the multiplicative inverse. And in a similar fashion down here, you'll get that B is equal to 5. Say equal or congruent. It's a little more accurate to say equal, I suppose. Okay. The reason there is 5 times 17 is 85. 85 minus 1 is 84, and 6 times 14 is 84. Okay. So we found the two multiplicative inverses, and let's continue here. Now, this takes a little bit of time. You guys can verify it yourself. I put the dot in here. It may or may not enhance the readability, but this by form alone is a solution to the original congruence. The reason is 14 is congruent to 0, so it'll go away in the mod 14 form up there. 14 is congruent to 0, mod 14, of course, and 17 is congruent to 0. And I'm not going to plug it back. You guys can verify this on your own if you want to, but 17 is congruent to 0. And the fact that 14a is 1 and 17a is 1 also you can see clearly why X is a solution to both this one and this one. Again, plug it in and verify, but it's just very formal. It's not too much thinking going on right there. Okay, so what we do right here is we already know that A is 11, B is 5, and so I did all that work for you right down here. Here's the 11 that we got right here. You see the 11 right here is the 11 we got up there, and then the 5 that you see here is the 5 that goes right there. All right, now when you multiply that, you get X is equal to 2358. And you can check that if you want to, but that is a solution to the original equation. Okay, that is a constructed solution to the original equation by using nothing but multiplicative inverses in constructing something that makes sense rather than memorizing the Chinese remainder theorem. Okay, now remember, we're looking for the greatest negative number that satisfies this condition. That can be obtained by just dividing 14 times 17, which are the two moduli, into 2358. And you'll find out we need for n to be 10. Okay, so n equals 10 will actually is the first integer that makes this negative. Again, guys, you can verify that, but n equals 10 implies that x is equal to negative 22. Okay, x is equal to negative 22, which is your answer. Now, a lot of you may doubt, that that's the answer. But okay, let's check it. Let's go back up and substitute it, okay? And remember, this is the greatest negative integer, right? Negative 1 is the greatest negative integer, right? That there's no greatest positive integer, but negative 1 is the greatest negative integer. We got x equals negative 22. And y'all, the work involved here was just to divide 14 times 17 into 2358 and realize you needed to go up one more integer to get it to be negative, okay? I didn't show that work, but it's not very difficult to do that. Now let's go up here and check, okay? Notice that if you put minus 22 in right here, okay, you get minus 28, and 14 does divide. This is, you guys have seen this notation, I'm sure. Right? Again, that's obtained by putting minus 22 right there, right? Okay. So you can minus 22 minus 6 is minus 28, and 14 divides that. Now, if you put minus 22 right here, minus 22 minus 12, and you can just think of this however you want. Minus 22 minus 12 is minus 34, and 17 also divides minus 34. Now, I was wondering how many people would guess and check this. It's not as easy as it looks, I don't think, to guess and check here. You don't really, the numbers are too big, in my opinion, to guess and check. Surely I'll have a commenter say, oh, I just guessed and checked. But you never can trust people like that. You don't know what they're doing, But I don't think this is particularly easy to guess and check. Somebody with a lot of number sense might have guessed and checked that negative 22 is the answer here. But I sort of doubt it. You got too many variables floating around here. A trained mind would just go, well, I need 14 to be, minus 2, minus 34. Those are small numbers. And but why would you think of those? It's not, you may or may not think of it. Okay. So, but in any event, that does it, folks. Minus 22 does satisfy that. And any other solution, notice that the reason why you can tack this on is 14 times 17 times n is trivially congruent I'll put congruent to 0 mod 14 times 17, right? So they're an infinite number of solutions. We wanted the largest negative solution. All right. Let me know what you think, and let me know if you thought, if you guessed and tested and got the answer. Let me know what motivated your thought process. All right. So anyway, thanks for viewing.